Hey there guys, here we're walking through Edexcel's Higher GCSE Maths Paper 3 from June 2018. So, the people that I heard from liked this paper. It was much nicer than the other two. So hopefully we're going to find this alright. I'm going to put useful links down below in the description. Paper 1 and Paper 2 will be down there. Your formulas that you need, they're going to be down there. Secret calculator tricks, they're going to be down there. And also any topic playlists that I have to help with topics on this paper. Let's do this. Question 1. A scatter diagram shows information about 12 girls. It shows us the age of the girl and the time they take to run 100 meters. So, there's our lovely scatter diagram. So we've got age along the bottom and then the time in seconds going up the side. Part A asks us to write down the type of correlation. So that means it's asking us how the data is linked. So we can see here as age increases, then the time in seconds is decreasing. So we're going down from left to right. So this is negative correlation. Cool. Part B says Christina is 11 years old. Her best time to run 100 meters is 12 seconds. We are told the point representing this data would be an outlier. We're asked to explain why. So let's find it. We want to plot the point 11, 12. So find 11 along the bottom and then 12 is this point here. So we can see that that point doesn't fit with the other points. So it doesn't fit in well with the other data. And that is exactly what we can say. Point doesn't fit with the others. Okay, then part C. Debbie is 15 years old. She says the scatter diagram shows I should take less than 12 seconds to run 100 meters. We want to comment on her statement. So, the highest age that the scatter diagram shows is 14. So really, 15 is out of the range of the scatter diagram. So it's not really reliable for ages above 14. So we could just say 15 is out of the age range for the scatter graph. So if we think about that, the time it takes people cannot keep decreasing, because then you would get down to silly times like 1 second or 2 seconds. So it's going to get to a point where everyone roughly is starting to run it in the same amount of time. So really, the scatter graph doesn't show us information for 15-year-olds, so that's not reliable. Okay, part 2, question 2. One says to expand and simplify this guy. So, let's expand the brackets. So, 5 times p plus 3 is 5p plus 15. And then we go minus 2 times 1. So that's minus 2. And then we go minus 2 times minus 2p. So that's going to give us plus 4p. So we got 5b plus 4b, which is 9b. And then we got 15 minus 2, so we got plus 13. 3. We have a trapezium drawn on a centimetre square grid. And what we want to do is, on the grid, draw a triangle equal in area to the trapezium. So we're going to need to work out the area of the trapezium. So, with a trapezium, if we call the top A, bottom B, and the height H, the area is height times A plus B all over 2. So here we need to find the area of the trapezium. So the top is 2 and the bottom is 7 and the height is 4. So the area is 4 lots of 2 plus 7 all over 2. So that's 4 times 9, which is 36, divided by 2 is 18 centimetres squared. So we need a triangle with an area of 18 centimetres squared. So I think I'd always go for a right angle triangle. So if we had one with a height of 6 and a length of 6, then 6 times 6 is 36. Half of that is 18. So that's the one I'm going to go for. In the real thing, use a ruler. So there's my height of 6. My length of 6. And then there's the hypotenuse. So that would be a perfect answer. 4. When a biased dice is thrown once, the probability it lands on a 4 is 0.65. The biased dice is thrown twice. Amir draws this probability tree diagram for the situation. The diagram is not correct, and the question asks us to write down 2 things wrong with the tree diagram. So let's see what we can see. On the first branch, probability that we land on a 4 is 0.65. That's right. And then the probability of not landing on a 4 is gone 0.25. So remember, probability always has to add up to 1. So we could say 0.65 add 0.25 is not equal to 1. So there's his first mistake. Okay, let's look up on the top branch of the second throw. So what he's done here is now set the chance of landing on a 4 is 0.35 and the probability of not landing on a 4 is 0.65. So this is wrong too. So on the second throw, the probability of landing on a 4 should still be 0.65, so it shouldn't change, and he's changed it, so there we go. Question 5, we got a right angle triangle with two side lengths, and we are asked to work out the size of angle ABC. So that is this chap here. So it's a right angle triangle, we're thinking SOHCAHTOA. Label the sides. So we got the adjacent here and the hypotenuse. So is it SO? No. CA? Yes. CAH. So CA tells us cos of the angle. So let's say cos of theta is 7 over 11 adjacent over hypotenuse. So theta is the inverse cos of 7 over 11, which to one decimal place, as they want it, gives us theta is 50.5 degrees. Cool. I'll put my SOHCAHTOA stuff down below. Now we're told the length of side AB decreases by 1 centimetre. The length of the line BC stays as 7. Angle ACB is still a right angle. Will the value of cos ABC increase or decrease? So be careful here. We're not being asked now to find the angle. We are only interested in what happens to cos of the angle. So it's the hypotenuse that now decreases by 1 centimetre. So it's now going to be 10 centimetres. So remember, ABC is this angle here. So cos of that angle is now 7 over 10. So cos ABC is now 7 over 10. Now it was 7 over 11. 7 over 10 is bigger than 7 over 11. So 7 tenths is greater than 7 elevenths. So it increases. In 6, there are some counters in a bag. Counters are either red, white, blue, or yellow. Bob is going to take a counter from the bag at random. The table shows the probabilities of getting a blue or a yellow. We are told there are 18 blue counters in the bag. The probability of getting a red is twice the probability of getting a white. We want to work out the number of red counters in the bag. So, quite a big question. First thing we can do is work out the probabilities of red and white. So we know probability has to add up to 1. So at the moment in the table we've got 0.45 add 0.25, which is 0.7. Now, together then, the probability of red or white is 1 minus 0.7, which is 0.3. So, between red and white, they make up 0.3 of the total probability. Now we know a red is twice as likely as a white. So you might be able to see this simply. For those that can't, what we need to do is split 0.3 in the ratio red to white, 2 to 1. So if we add 2 plus 1, we get 3. Divide 0.3 by 3, and we get 0.1. Multiply that by each part of the ratio, and we get 0.2 to 0.1. So now we know the probabilities of getting a red and a white. Okay, next we need to somehow work out how many counters are in the bag in total. Now, we are told that there are 18 blue counters, and we know blue makes up 0.45 of the total probability. So, I'm going to turn 0.45 into a fraction, which your calculator can do for you. Just put in 0.45, press equals, and it will give you 9/20. So we know 9/20 of the total counters is equal to 18. So if we divide by 9, 1/20 is equal to 2 counters. So if we then multiply by 20, total counters is equal to 2 times 20, which is 40. So the number of red counters is the probability of red times the total counters. So the total red is 0.2 times 40, which is going to give us 8. So 8 is our answer. Okay, and then part B says a marble is going to be taken at random from a box of marbles. The probability that the marble is silver is 0.5. There must be an even number of marbles in the box. We need to explain why. So 0.5 is 1/2. So we can't have part of a marble. So we can't half an odd number of marbles. Question 7 wants us to solve 5 minus x over 2 is equal to 2x minus 7. So the very first thing we should do here is get rid of this fraction. So on the left, we got 5 minus x divided by 2. So we're going to multiply both sides by 2. That doesn't affect the top of the fraction. It's already being divided by 2, so multiplying by 2 simply cancels that out. So we get 5 minus x is 2 times the right hand side. So 4x minus 14. Okay, my next step would be to get the x terms on the same side. So on the left, we got a minus x, so I'm going to add x to both sides. So then we got 5 is equal to 5x minus 14. Add 14. Yeah, 19 is equal to 5x. And finally, divide by 5. And we get x is 19 over 5, or 3.8. Cool. So we got this pentagon. We know 3 of the angles, 90 degrees, 115 and 125. We're told the angle BCD, so this bottom right one, is 2 times angle ABC, which is the top right one. We want to work out the size of angle BCD. So, what I'm going to do, I'm going to call angle ABC X. And then we know BCD is twice as big, so twice as big as X is 2x. Okay, now we need to know what the sum of the interior angles of a pentagon are. So you might know this. If you don't, there's a nice little trick. So what we do, we draw a pentagon. Any old pentagon, doesn't have to be perfect, which is lucky when you draw like me. Now what we do, from one of the points, we draw a straight line to any other corner or vertex that we can. So I'm going to go from the top down to the bottom left and the bottom right. So what we've done inside of this pentagon, we've created 3 triangles. Now we know angles inside a triangle add up to 180. So the sum of the interior angles is 3 times 180, which gives us 540 degrees. So we now know these 5 angles have to add up to 540 degrees. So we know 3 of these angles, 125, 115 and 90. So if we add those up, 115 add 125, so that's 240. Add 90 is 330. Now, if we take that off of 540, we're going to get what's left for these other 2 angles. So 540 minus 330 is 210. So we know these other 2 angles, x and 2x, have to add up to 210. So 3x is 210. Divided by 3x is 70 degrees. So remember the angle that we want is BCD, which is 2x. So finally, BCD is 2 times 70, which is 140 degrees. Good times. Question 9, so we got t is equal to the square root of w over d cubed. We tell w is 5.6 times 10 to the minus 5, d is 1.4 times 10 to the minus 4. We want to work out the value of giving our answer to 3 significant figures in standard form. So really we want to be typing this thing into our calculators. First of all, be really careful with how you type it in. If you type it in exactly like this, hopefully you'll get the same answer. So we want the answer to 3 significant figures. So we got 4,517 point blah blah blah. The third significant figure there is the 1. So the 1 has a 7 after it, so it's going to round up to 2. So, to 3 sig figs, we get 4,520 in standard form. That is 4.52 times 10 to the power 3. For part B, we're told W is increased by 10%, D is increased by 5%. Lottie says the value of D will increase because both W and D increase. Lottie is wrong, we want to explain why. So, if W is increased by 10%, we could say we've now got T is equal to the square root of W times 1.1 up on top, and then if D is increased by 5%, now remember, be careful here, D is being cubed. So if we increase D by 5%, we could write that as D times 1.05. And that is all cubed. Now, what we can do is split up this fraction. So we can say we got the square root of W over D cubed times 1.1 over 1.05 cubed. So, by the rules of thirds then, we can write this as square root of W over D cubed times the square root of 1.1 over 1.05 cubed. So, W over D cubed, remember, is just T. So we got T times, now if we work out the value of the square root of 1.1 over 1.05 cubed, we get 0.97. So T is actually decreasing by 3%. Bit tricky. Another way that we could have done that is to increase the actual numbers by the percentage and work out what the answer would be, then compare it to what we got up above. So that would work too. Okay, question 10. So we got 3 lamps, lamp A, B and C. Lamp A flashes every 20 seconds, lamp B flashes every 45 seconds, and lamp C flashes every 120 seconds. The lamps start flashing at the same time. We are asked how many times will the 3 lamps flash at the same time in 1 hour. Okay, so this is really a lowest common multiple question, I guess. So, lamp A flashing every 20 seconds and lamp C flashing every 120 seconds is not a problem. Every time lamp C flashes, lamp A is going to flash, because 20 goes into 120. So the problem that we have here is how often are lamp B and C going to flash. So what we're going to do is write down some multiples of 45 and write down some multiples of 120 and see what the lowest common multiple of these two numbers is. So let's do C first. So it's going to be 120, 240, 360. No, I think that'll be enough. 45s go 45, 90, 135, 180. Now we know because 120, or multiples of 120, only end in zeros, we only need to worry about the multiples of 45 that end in 0. So the next one would be 225, but we know that's useless. So the next one's going to be 270. So we're adding 90 every time. So the next one, quite happily, is going to be 360. So the lamps flash together every 360 seconds or 6 minutes. 60 seconds in a minute, remember. So an hour is 60 minutes. So 60 divided by 6 is 10. As a little side note, I just checked the mark scheme for this one because I thought it was a bit dodgy. Do we count the flash at the start? So you would be alright with an answer of 10 or 11. So 11 would be counting the flash at the start and then the next 10 over the hour. So 10 or 11 is fine here. Okay. Question 11, we got some reverse percentages, so I'll put my stuff on that down below. In 2003, Jerry bought a house, very nice. In 2007, he sold the house to Mia and made 20% profit. In 2012, Mia sold the house for £162,000. She made a loss of 10%. We want to work out how much Jerry paid for the house. So we need to work backwards through this story. So when Mia sold the house, she made a 10% loss. So a 10% loss means she sold the house for 90% of what she paid. So that means then 90% of what Mia paid is £162,000. So from this we can use reverse percentages to work out how much she paid for the house, which is the amount Jerry sold the house for. So if we divide by 9, we would get 10% was £18,000, so 100% is £180,000. Okay, so now let's swap to Jerry. So that means Jerry sold the house for £180,000. Now, we know when Jerry sold the house, he made a 20% profit. So profit means he got back what he paid for the house, and then he made another 20%. So, we can say 120% of the cost to Jerry is £180,000. So, using reverse percentages again, if we divide by 12, we get 10% was 15,000, and then multiply by 10, 100% is going to be £150,000. Cool. Question 12. The graph shows the volume v litres of liquid in a container at t seconds. So here's our lovely graph. Part A wants us to find the gradient of the graph. So gradient is difference in y divided by difference in x. So we need to find two nice coordinates and do just that. So we're going to go with this one, which is 0, 4, and I'm going to go with the right guy, which is 8, 16. Okay, so we got a y value of 16. So the gradient is the difference in y, so 16 minus 4 divided by the difference in x, which is 8 minus 0, So we got 12 over 8, which is 3 over 2. Cool. B wants us to explain what this gradient represents. So not only does it show us that the container is filling up, it tells us the rate at which the container is filling up. So it tells us the rate at which the container is filling. Cool. And then part C says the graph intersects the wire, the volume axis at L equals 4. We want to explain what this intersect represents. So the intercept happens at time t equals 0. So this intercept is the starting volume of liquid. Cool. Question 13, we got two similar shapes, A and B, clearly chess pieces. We're told the surface area of A to the surface area of B is 3 to 4. The volume of shape B is 10 centimeters cubed. We want to find the volume of shape A, giving our answer to 3 significant figures. So, starting with the surface area ratio, that's 3 to 4. From that, we can get the ratio of the lengths of the two shapes. So, to get the length ratio, we square root the surface area ratio. So we're going to get root 3 to 2, and I should have put A and B above. We can then get the volume ratio by cubing the length ratio. So the volume ratio is root 3 cubed to 2 cubed, which is 8. Okay, so now we know the actual volume of B. So we can use the actual volume and this last ratio. So the actual volume well, we know that the right hand side of the ratio is 10. So now we need to ask ourselves, how have we got from 8 to 10? What is this scale factor? So we could do here 10 divided by 8 gives us 1.25. So to get from 8 to 10, we've multiplied by 1.25. So the left hand side of this ratio, the volume of A is root 3 cubed times the scale factor 1.25. Now if we put that into our calculators, we get 951 blah blah blah. Volume 84951 blah blah blah. They want it to 3 sig figs though. So the third sig fig is the 9. Now the 9 has a 5 after it, so effectively the 9 rounds up to a 10. So to 3 significant figures, we get 6.50 centimetres cubed. Question 14. There are 16 hockey teams in the league. Each team plays 2 matches against each of the other team. We want to work out the total number of matches played. So, the way I'm going to do this is imagine there's 16 games were in a table. Now, I'm not going to draw the whole table. Let's just put team 1, 2, and 3 in the table. Hopefully this will give us an idea of what's going on. So team 1 cannot play team 1, team 2 cannot play team 2, team 3 cannot play team 3. Along the first row though, we can say, well, here 1 is playing against 2, and then 1 is playing against 3. Then going down the first column, we can say here 2 is playing 1 and 3 is playing 1. So we can see using a table like this, we've laid it out so that we get the 2 matches between the 2 different teams. So we can then, well, we got then 3 versus 2 there. Here we got 2 versus 3. So in our little 3 by 3 table with 3 teams, the total number of matches is 3 squared, which is 9, minus the 3 crosses. So that gives us 6. So if we were to extend this table for all 16 teams, we would have 16 squared minus 16, which gives us 240. Cool. Question 15. The graph shows the speed of a car in meters per second of a journey over the first 20 seconds. So there's our lovely graph. Part A wants us to work out an estimate for the distance travelled in the first 20 seconds. We want to use 4 strips of equal width. So what we're going to be doing is drawing trapeziums underneath the curve. So the area underneath a speed time graph gives us the distance. So the strips we're going to use are going to be equal in width. So we got 20 seconds, 20 divided by 4 is 5. So I'm going to draw on our strips here. Okay, so there are the strips, the triangle and the trapezium are drawn on the graph. Now what we need to do is work out the area of each of them. So a little reminder on area of a trapezium. We call the height H, the top length A, and the bottom length B. The area is the height times A plus B, all divided by 2. Okay, so first up we got a triangle. Now this triangle has a height of 22 and a width of 5. Area of a triangle is base times height divided by 2. So here we get 55 for the triangle. The first trapezium, A and B, are 22 and 28. H is 5. So 22 add 28 is 50, times by 5 is 250, divided by 2 is 125. Second trapezium, A and B are 28 and 32. So 28 add 32 is 60. Multiply that by 5, we get 300. Divide that by 2, we get 150. And then the last one, A is 32, B is 35. Add those together, we get 67. Multiply that by 5, we get 335. Divide that by 2, and we get 167.5. So we now add those together. So we got 55, add 125, add 150, add 167.5. And that is going to give us a total of 497.5. And that is meters. So this is one where in the answer there's a bit of a region for error. So if you've got an answer somewhere in that region, you're golden. Okay, then part B asks us, was our answer an overestimate or an underestimate? So if we go back to the graph, we can see here the trapeziums fit quite well, but the triangle at the start has all of this area here that is under the curve but above the triangle. So we've missed out on some of the area. So it's an underestimate. And I guess the reason we could say, well, because the shapes are under the curve. So we don't have the total area. Cool. Question 16. So, the nth term of a sequence is given by an squared plus bn, where a and b are integers. We're told the second term is -2 and the fourth term is 12. We want to find the sixth term of the sequence. So to be able to do that, we're going to need to work out the values of a and b. To do that, it's going to be simultaneous equations. So we know when n is 2, so the second term, well, we know that that is equal to -2. But we know that a times 2 squared add 2b is -2. So 2 squared is 4, so we get 4a add 2b is -2. And then we know the fourth term, so we can say when n is 4, well, this time we get a times 4 squared, which is going to give us 16a add 4b, and that is equal to 12. Okay, so we now need to solve these simultaneous equations for A and B. Now, we can actually divide both equations here to get the same amount of B. So, equation 1 has a common factor of 2. So if we divide that away, we get 2a and b is minus 1. And the second equation has a common factor of 4. So if we divide that away, we get 4a and b is equal to 3. So these are the two equations that we're now going to be playing with. Okay, so let's call the top equation 1 and the bottom equation 2. Both of these have a single positive b in them, so we can get rid of that nice and easily by doing equation 2 minus equation 1. So 4a take 2a is 2a, b take away b is 0, and then we got 3 minus minus 1, which is 3, add 1, which is 4, therefore a is equal to 2. So, now that we know what a is, we can work out what b is. So, if we use equation 1, we know 2 times 2, so 4 plus b is equal to minus 1. So, b is equal to minus 5. So now we know the sequence is 2n squared minus 5n. So that is the sequence. Now we want the 6th term, so when n is 6, well, we're going to get 2 lots of 6 squared. 6 squared is 36. 2 times 36 is 72. And then we got minus 5 times 6, so it's minus 30. We get 42. So the 6th term is 42. Cool. Then for part B, we got the first 5 terms of a different quadratic sequence. We want to find an expression in terms of n for the nth term of the sequence. So, first step, find the differences. So 0 to 2 is 2, 2 to 6 is 4, 6 to 12 is 6, 12 to 20 is 8. Find the difference of our differences. So we're adding 2 each time. So that tells us the quadratic part of this sequence is, well, half of 2 is 1. So the quadratic part is n squared. So now we write down the first few terms of n squared. So we got 1, 4, 9, 16, that will be enough. So now we take the quadratic part away from the whole sequence. So what that does is leave us with the linear part of the sequence. So 0 minus 1 is minus 1. 2 minus 4 is minus 2. 6 minus 9 is minus 3. And 12 minus 16 is minus 4. So this has given us the first 4 terms of the linear part of the sequence. Now each time, to get from term to term, we're subtracting 1. So the linear part is minus n. So the whole sequence is n squared minus n. I'll put my sequences stuff and simultaneous equations stuff down below. Question 17, we got 2 triangles stuck together to make this shape. Question wants us to work out the length of AD. So that is this length here. So we got 2 triangles. Both of them are non-right angle triangles. In the top triangle, we only know one side and one angle. So at the moment, we don't have enough info to work out the side that we want. So if we then look in the bottom triangle, well, things down here are a bit more useful. We know 2 angles and 1 side. Now we know a matching pair of side and opposite angle. So we can use the sine rule in this bottom triangle to work out this length BD. So for now, I'm going to call this length A. So by the sine rule, we know that A over sine 34 is equal to 12.5 over sine 109. Now we want to get A on its own, so we're going to multiply both sides by sine of 34. So we get A is 12.5 sine of 34 all over sine of 109. Now if we put that into our calculators, we should get A is 7.39 centimeters. So we now know that this side here is 7.39 centimeters. So now in this top triangle, we now know 2 lengths and 1 angle. We don't have a matching pair of side and angle, so we're now going to have to use the cosine rule. So again, I'm now going to call the side that we want A again. The reason I keep using A here is because the formulas that we use are always in terms of A. So label things to make them easier for yourselves. So, in fact, what I'm going to do is just make a sketch of this triangle down here, calling this side A, this length 7.39, this length is 11.4, and the angle is 86. Okay, so by cosine rule, we know then that a squared is equal to 7.39 squared add 11.4 squared minus 2 times 7.39 times 11.4 times cos of 86. So, if we put that loveliness into our calculators, then we are going to get 172.8. Now that is a squared. So a squared is 172.8. So we then need to square root. So a is 13.145 blah blah blah. The question though wanted our answer to 3 sig figs. So we get 13.1 centimetres. I'll put my sine and cosine rule stuff down below. Question 18a wants us to show the equation x cubed add x equals 7 has a solution between 1 and 2. So when we're talking a solution, we mean a value of x. So when x equals 1, we get 1 cubed add 1, which is equal to 2. When x is equal to 2, we get 2 cubed add 2, which is 8 add 2, which is 10. Now, 7 is bigger than 2 but less than 10. Therefore, solution is between x equals 1 and 2. Part B wants us to show that the equation x cubed add x equals 7 can be rearranged to give x is the cube root of 7 minus x. So, notice that we want the cube root on the right hand side. So we got x cubed add x is equal to 7. Take away the x, we get x cubed is equal to 7 minus x, and then cube root x is the cube root of 7 minus x. Okay, now part C, starting with x naught is equal to 2. We want to use the iteration formula xn plus 1 is equal to the cube root of 7 minus xn to find an estimate for the solution to x cubed plus x is equal to 7. So there is a really nice easy way that we can use our calculators to do this. That's explained in my iteration video, which I'll put down below. basically what we're doing is x1 is equal to the cube root of 7 minus x naught. So 7 minus 2. Now that's the cube root of 5. So for that, we get 1.70998. Now that does keep going on. Well, that should be enough decimal places. So x2 is equal to the cube root of 7 minus x1. So minus the 1.70998. Okay, now that gives us 1.7424. This time to 4 decimal places, I think that'll be enough. The only reason I went to 5 in the first one is because it rounded weirdly if we went to anything less than 5. And then x3 is the cube root of 7 minus 1.7424, which gives us 1.738. So there we go, we've used the formula 3 times, that's our estimate. Question 19, we got 2 right-angled triangles. The left-hand side one has a height of x and a base length of 4x minus 1, and it's got this angle E. And then the other one has a height of 6x plus 5 and a base length of 12x at 31 with an angle of F. Now we are told tan E is equal to tan F, and our mission is to find the value of x. So for this we need to remember TOA from SOHCAHTOA tells us tan theta is equal to the opposite over the adjacent. So in each of these triangles we have the opposite and the adjacent to the angle. So tan of E is equal to x over 4x minus 1. And tan of F is equal to 6x plus 5 over 12x at 31. Okay, now we know tan E and tan F are equal. So we can say x over 4x minus 1 is equal to 6x plus 5 all over 12x add 31. And this is now the equation that we need to solve. Okay, so the first thing we need to do is get rid of the fractions. So let's start by moving 4x minus 1. So to do that, we multiply both sides by 4x minus 1. So that's going to give us x is equal to 4x minus 1 times 6x minus 5 over 12x plus 31 Now we're going to do exactly the same thing with 12x at 31. Multiply both sides by it, and then we get x times 12x at 31 is equal to 4x minus 1 times 6x add 5. Okay, so now we want to expand the brackets. So, on the left, x times 12x is 12x squared. X times 31 is 31x. Okay, now the right is going to be a little bit trickier. Use whatever method you like to use to expand brackets. So, 4x times 6x is going to give us 24x squared. Now if we do 4x times 5, then we get 20x. If we do minus 1 times 6x, we get minus 6x. And then if we do minus 1 times positive 5, we get minus 5. Okay. Now let's simplify the right hand side. So we got 12x squared add 31x is equal to, so we got 24x squared now we got plus 20x minus 6x, so that is giving us plus 14x, and then we got the minus 5 at the end. Okay, so this chap is a quadratic equation. To solve quadratics, we need everything on the same side with a nice 0 on the other. The next thing we need to do is move the 12x squared and the 31x. So, we're going to subtract 12x squared. So we're going to get 12x squared, 24x squared, minus 12x squared is 12x squared. And then we're also going to subtract 31x. So 14 minus 31 is 17. Sorry, minus 17. So we get minus 17x minus 5, and that is all equal to 0. Okay, so there's our quadratic in all its glory. I think we are able to factorise it. So it's definitely not a nice quadratic, I got a really nice trick for factorising these guys. I'll put a link to my video down below with far more examples. So, step 1 is we multiply the coefficient of the x squared term by the number at the end. So 12 times minus 5 is minus 60. Now, what we now need are two numbers that add together to minus 17 and multiply together to minus 60. So, if we run through our factors of 60, hopefully the answer will present itself. So we got 1 and 60. There's no way, if we make one of those negative, there's no way we can get a minus 17. We got 2 and 30. No. We got 3 and 20. Winner, winner, chicken dinner. So, if we had positive 3 and minus 20, 3 minus 20 is minus 17. 3 times minus 20 is minus 60. So, what we do now is, however many x squareds we have, we open two sets of brackets and stick in that amount of x. So we got 12x squared, so we're going to have two brackets with 12x in them. Okay, now in each of the brackets we put one of those two numbers. So we're going to put a plus 3 and we're going to put a minus 20. Now the very last step here is to divide away any common factors inside a set of brackets. So this first bracket has a common factor of 3. So this bracket divides to 4x, add 1, and the second bracket divides, well, it has a common factor of 4, so this guy divides to 3x minus 5 is equal to 0. So from that we can get two solutions for x. So remember, to get solutions we set what is inside a bracket equal to 0 and solve for x. So this first bracket will tell us 4x plus 1 is equal to 0, 4x is equal to minus 1, so x would be minus a quarter. However, stop and think about that. Remember, x is a length of the triangle on the left, so x cannot be negative. Length is definitely always positive. So that is not a valid solution. So the other bracket, this would be telling us 3x minus 5 is equal to 0. Add 5, 3x is equal to 5, divide by 3, x is equal to 5 over 3, 5/3, so that is our answer. Okay, question 50. We're told 50 people were asked if they speak French, German or Spanish. we got quite a lot of info about them. We are asked, 2 of the people are chosen at random, what is the probability that they both only speak Spanish? So we need to work out how many of them only speak Spanish. We need to process all of this information, so we're going to need a Venn diagram, which is going to look something like that. So what we're going to try and do now is fill in as much of this as we can using the information. So, first of all, 31 people speak French. Not useful to us yet, because we don't know how many of them speak other languages too. 2 people speak French, German and Spanish. So we can put that one in. That's going to go in the middle where all 3 circles intersect. 4 speak French and Spanish, but not German. So we can put those in down there. Okay, we're told 7 speak German and Spanish. Now be careful here, because that's not saying, but not French. So in total, 7 people speak German and Spanish. Now we know 2 of those are already in the middle. They speak French as well. So 7 people in total speak Spanish and German. So that only leaves 5 more to go in that part. We're told 8 people do not speak any of the languages. So that 8 goes on the outside. Now we're told all 10 people who speak German speak at least one of the other languages. So that tells us 2 things. 0 people only speak German. Now we know there are 10 people though who speak German in total. At the moment we got 2 and 5 of them, so that's 7. That tells us then 3 of them speak German and French. That now allows us to work out how many people only speak French, because we know there are 31 people in total that speak French. So at the moment we got 3 and 2 and 4 of them. So 3 add 2 add 4 is 9. 31 minus 9 is 22. So 22 people only speak French. So now that only leaves us then with the people that only speak Spanish. We know there are 50 people in total. So if we add up everything that we've got, well, we know 31 people are in the French circle. So we then need to add on the 5, that's 36, and then the 8 on the outside adds up to 44. So that means 6 people speak only Spanish. So now we need to work out the probability that 2 people chosen at random speak only Spanish. So the probability of the first one is 6 out of 50. Now for the second choice, there's going to be 1 less person who speaks only Spanish and 1 less person in total. So we now multiply this by 5 over 49. stick that in your calculator and you will get 6 over 490, or it might simplify it to 3 over 245. Cool. Okay, question 21, the grand finale. So, ABCD is a parallelogram. We're told ABP and QDC are straight lines. Angle ADP is equal to angle CBQ, which are both equal to 90 degrees. We want to prove triangle ADP is congruent to triangle CBQ. So, first thing I'm going to do is make a little sketch of each triangle. So, ADP is that guy. And triangle CBQ is this guy. So it's QC. Okay. So what can we say straight away? Well, first of all, they both have a right angle in them. So that's a good start. So we could say angle ADP is equal to angle QBC, which is equal to 90 degrees. So that's an equal angle. Okay, what else can we say? We could say, well, AD is equal to BC in length. So this side here is equal to this side here. So on our triangles, this length is the same as this length. So the reason for that, AD is equal to BC, and that is because opposite sides of a parallelogram are equal. So opposite sides are equal. Okay, we need to find one other thing then, either another side or another angle. So, what else do we know about parallelograms? Well, we know that their opposite angles are equal. So we know that this angle here is the same size as this angle here. So that's the last thing that we need. So we can now say, well, this angle here is the same as this angle here. So angle DAP is equal to angle QCB again, opposite angles are equal. So we've got angle, side, angle, So they are congruent. Cool. Okay, and then the final part wants us to explain why AQ is parallel to PC. So, we want to work out or explain why AQ, this guy, is parallel to this guy. Okay, so, well, we know that AP, so AP and QC well, we know that each of those lengths are the hypotenuse of the same two congruent triangles. So, the hypotenuse, can't spell, of two congruent triangles so they are equal. Okay, so we are saying this whole top length is equal to this whole bottom length. AP is equal to QC. Now we know as well that AP and QC are parallel, so this must mean then they are equal length and parallel, so they must be opposite sides of a parallelogram. So we can say AP and QC, AP and QC are also parallel. So that means the whole shape so APQC is a parallelogram so AQ has to be parallel to PC. Cool. Okay guys, that's the paper done. Really hope you found it useful. Don't forget to give us a thumbs up, get subscribed, share with your friends. Take it easy, take care, good luck with your exams.